All right, we're going to do part two on the definition of the derivative today. And basically in part one, we learned the definition of the derivative and how to find f prime of x. And what we did, we only used it for one thing. We used it to find the slope of tangent lines. Now what we're going to do for today is we're going to extend that question a tiny bit at the end. And instead of just finding the slope of the tangent line, we're actually going to find the equation of the tangent line. So basically all we're doing is adding a tiny bit to the end of the question. So when you're looking at today's assignment, probably like 90 or 95% of the work you're doing is going to be that first step where you're finding f prime of x. And that's mainly what today's assignment is for, is extra practice with the definition of the derivative. But in addition to that, we are going to learn one little new thing. Now before I show you how to do it, I do want to mention this is actually a real common question in AP Calculus. So a lot of you guys are going to be taking the AP Calc test in like a year and a half. So not at the end of this class, but at the end of next year, if you take AP Calc, when you take that test, you're going to see this type of question on there. There's going to be questions on that test that say, here's a function, find the equation of the tangent line, and you're going to have to know how to do that. So this is an important lesson. All right, here are the steps to doing it. Step one, and this is what I said is going to be like 90 to 95% of the work. Repeat yesterday's homework, find f prime of x, use it to find the slope. Now, if I want to do the equation of the tangent line, I need one more thing. In fact, if I want to do the equation of any line, I need the slope, and I need one point on the line. So that's step two. We got to find a point. Now, what I said here is you're going to take your x value, x equals c or x equals 2, whatever it is. You're going to plug that number into the original function to find the point. And then I said unless it's given. So let me mention that for a sec. There's kind of two ways this question can be worded. I can say find the slope of the tangent line at the point, and let's say the point is like 2, 5. Now if I do that, you don't need to do step 2. I've basically given you the x1 and the y1, and you're going to use those. But the other way to word that question, this is what I was talking about in step 2 over there. I said the other way to word this question is find the equation of the tangent line when x equals 2. See, then I've given you the x or the x1, but you have to plug it back into the function to then find the y1 that goes with it. It's not a hard thing, but it's just something you got to look for. So read each question carefully. Sometimes the point is given in the question and you have both the x and the y. Sometimes you're only given the x and you need to use it to find the y. But basically, once you have the slope and you have a point on the line, here's something you learned probably back in freshman year. It's something called point-slope form. Y minus y1 equals m times x minus x1. And basically, at this point, you have everything you need. Because up here in part 1, we found the slope, that's m. So I would put that right here. And then this point that we just found in number 2, or maybe was actually given to us in the question, we put the x1 here, we put the y1 here, and we're completely done. Now your other choice here, if you don't like point-slope form, is to use what's called slope-intercept form. That's y equals mx plus b. And you may be more comfortable with that because I think you probably used it more often. It's fine. You do the same thing. You take m from step 1, you put it here. You take your point. Now we don't call it x1 and y1, we just call it x and y, but you still substitute. You put the x value here and the y value here, but then you have a little bit of extra work. You have to solve for b, and then you have to go back and plug b back into the equation. So I usually skip that because I like to do the least work possible, and with point-slope form, you just plug in the numbers and you're done. With slope-intercept form, you have that one extra step where you have to solve for b. But if you're more comfortable with it, definitely use it. They're both fine. And what I want to do now is do an example of one of these whole problems from beginning to end. So this is our example. We're only going to do one today, and then we'll be done. It says find the equation of the line tangent to f of x equals 1 over x at x equals 2. So before I do anything else, if I'm doing tangent lines, let's just find f prime of x. I'm going to need it at some point, so let's just do it first. So I'm going to start with the definition of the derivative, which we just learned. That tells me that f prime of x is the limit as h approaches 0 of f of x plus h minus f of x all over h. So if you remember from part 1, I said the f of x plus h part, sometimes I like to go off and do that off to the side here. And what it means is you're taking every x in the function and replacing it with x plus h. Now this one, there's no extra work to. If I change that x in the denominator to an x plus h, I just get 1 over x plus h. So basically I have everything I need now. So I'm going to leave the limit part. It's still the limit as h approaches 0. Now f of x plus h is what I just found in the top right corner there. That's 1 over x plus h. Minus, and then f of x, that's your original function. That's 1 over x. It's right here. And the whole thing is over h. Now remember from part 1 we said when you're doing definition of the derivative, because that h is in the denominator and I'm doing the derivative as h approaches 0, you don't have to try direct substitution at this point because you're always getting 0 over 0. So what we want to do is right off the bat is find some way to cancel that h. And if you remember from our limit section, limits analytically, we did 3 main types of questions that we were focused on. And we did factoring, which I showed you an example of in part 1. We did rationalizing, which I showed you an example of part 1, and then we did complex fractions. So this is an example of the one type that I actually didn't go over with you in part 1. So then we'll have seen one of each. So this is how I like to think of it. When I'm going to clean this up, I'm going to multiply. It's a fraction. I can multiply top and bottom by whatever I want as long as it's the same thing. So what I say to myself is the first thing I want to do is cancel out this x plus h in the denominator. So I'm going to multiply top and bottom by x plus h. But I also want to cancel out this x in the denominator. So I'm also going to multiply by x. So basically I'm multiplying the top and bottom of the fraction by each little mini denominator that I want to cancel out. Now on top, it's basically a distributive property. I'm taking this and I'm multiplying it here first. So let me recopy my problem here. Still is limit as h approaches 0. And when you distribute, see this is where it cancels. Like when I multiply, this x plus h is going to cancel with the 1. I'm not going to cross it because we're going to distribute again. But basically, all it leaves is the x. And then you get the minus in the middle. And when I distribute here, this x cancels with the x, and it just leaves the x plus h. Now, the one thing you want to remember, the denominator isn't just h anymore. That's a common mistake here. A lot of times when I'm grading papers like this, I see the denominator as just h. The denominator got multiplied also. So the denominator has all 3 of these things. I would call it hx, x plus h. Kind of reorganize it so that the parentheses are at the end. All right, so let's keep going. Let's keep cleaning up here. I notice on top I have an x and a negative x. Basically I have a positive x in front and I'm subtracting from it the x in the parentheses. So I have the limit as h approaches 0. Now one thing you want to be careful of here, what you're left with on top is not h, it's negative h. Because remember, you are subtracting everything in that parentheses. So what's left over on top is negative h. And on bottom, I have hx times x plus h. And remember, in limit questions or in definition of the derivative questions, your goal is always to eliminate that h, to cancel the h, and we just did it. Because see, now at this point, I can cancel this h with this h. It leaves a negative 1 on top. And what I have now is the limit as h approaches 0 of negative 1 over x times x plus h. And your last step, remember, after you cancel those x or those h's, your last step is to do direct substitution with any h's that are still left. So if h is approaching 0, this x right here is basically going to disappear. So what we get is 1 over x times x, negative 1, or negative 1 over x squared. And that's our derivative. So remember, that was a ton of work, and I told you that's like 90% of the question. We're almost done. So let me clear my screen. And I'm going to recopy the important information. My original question, f of x was 1 over x, and x is 2 in this question. And what we just did all that work to find out is that f prime of x is negative 1 over x squared. So now we have everything we need to do the easy part. That was the hard part. Let's do the easy part. So let's do the slope first. For the slope, you take your x value, which in this question is 2, and you plug it into the derivative, f prime. You're basically finding f prime of 2. So that would be negative 1 over 2 squared, or negative 1/4. So m is negative 1/4. Now the other thing I need is a point, and remember I said sometimes in the question the point is given. In this case it wasn't. I gave you half the point. So if I tell you x is 2, I'm basically telling you the point is 2 comma something. But we still do need to figure out that something, and we find that by plugging 2 into the original function. So for my y value, I'm not going to find f prime of 2, I'm going to find f of 2. And that would just be 1 over 2, or 1/2, by plugging that 2 into the x up there. So my point is actually 2 comma 1/2, and now I have everything I need. The negative 1/4 is m, the 2 is the x1, and the 1/2 is y1. So we use point slope form. It was y minus y1 equals m times x minus x1, and basically just put the numbers in the right place. So you have y minus 1/2 equals negative 1/4 times x minus 2. Box that up, and that's your answer. Now, if you did want your answer in slope-intercept form, sometimes you do, or sometimes maybe it's a multiple choice question and the answers are in that form. If you're already in point slope form, it's actually really easy. Just distribute the 1/4 and combine like terms. Like if I just do this, if I distribute the negative 1/4 here, I would have y minus 1/2 equals, it would be negative 1/4 x plus, negative times negative is positive, and 1/4 times 2 would be 1/2. And then I would add 1/2 to both sides, and you would get y equals negative 1/4 x plus 1. 1/2 plus 1 is 1. So either of those two answers are fine. I personally don't care if you answer using point slope form or slope intercept form. It's good to know how to do both, but if this were an actual question, you could have just stopped at the red box. You don't need the light blue work. I was just showing you how to do that in case you ever need it.